All right, if W is an endpoint of segment WT and the midpoint is 5, -2, what's the ordered pair that represents point T? Okay, so this is an example of working backwards. We're given the midpoint and an endpoint, and we're working backwards to find the other endpoint of this segment. Well, let's start with the midpoint formula. The midpoint formula is x plus x divided by 2, comma, y plus y divided by 2. Now here's one of our x's and one of our y's, and then here's the actual midpoint. So let's plug this in for the midpoint. And let's plug this in for one of our x's. And plug that one in for one of our y's. So now they're telling us that this coordinate should equal this coordinate. That means that the x's should be the same and the y's should be the same. So essentially we're solving two different equations. The first equation we're solving is 5 equals 3 plus x divided by 2. And the next equation we're solving is -2 equals -4 plus y divided by 2. When I go to solve this one, I'm going to start by multiplying by 2 on both sides. So 10 equals 3 plus x. Same thing with this. I'm going to multiply by 2 on both sides. -4 equals -4 plus y. The last step to solve is subtract 3. So 10 minus 3 is 7. And the last step over here is to add 4. -4 plus 4 is 0. Okay, so it looks like the other endpoint that we were missing is 7, 0. Okay, let's move to number 13. This one is an example of working forwards. Okay, we're given both endpoints and we're trying to find the midpoint. So again, we're starting with the midpoint formula. Midpoint equals x plus x divided by 2. So 5 plus -3 divided by 2, comma y plus y. So -5 plus 1 divided by 2. Okay, it looks like when we go to simplify this one, we should be getting a +2 over 2. And it looks like this one is going to be a -4 over 2. So we can simplify this just a little bit further. That first coordinate's a 1. That second coordinate is a -2. So here's the midpoint of this segment RS. All right, now let's move to the partitioning a segment. Now guys, this is the super long formula that we covered prior to leaving for the quarantine. So this long formula is actually on your EOC formula sheet. So if you need to jot this down, pause the video, jot it down. But this is what I'm going to be plugging in. So here's my A, here's my B. Here's x1, y1, x2, y2. Now let's just plug this in. x1 plus A over A plus B times x2 minus x1. Okay, since I was subtracting a negative, it really became addition. All right, now it's y1 plus A over A plus B and y2 minus y1. So now the last thing we need to do is just kind of follow the order of operations, right? PEMDAS. Okay, we're going to first take care of what's in the parentheses. Okay, there's no exponent, so we're done with that. Now we're moving on to multiplication. Okay, you can let your calculator help you with this process. We're going to do parentheses 3 divided by 8 times 16. So that's going to be 6. And again, we're going to take care of the multiplication right here. That's 3/8 times -8, which is giving us a -3. And now that we've taken care of multiplication, there's no division, and now we're on to addition. So -1 plus 6 is going to leave us with a 5, and 8 plus a -3 is going to leave us with a 5. So 5, 5 partitions this segment into a ratio of 3 parts to 5 parts. Okay. Cameron partitioned a segment into a ratio of 1 part to 1 part, right? So that means if we were looking at this segment and we found the coordinate that partitioned it into 1 part to 1 part, right? 1 equal part to 1 equal part, that is essentially saying that we're looking for the midpoint of this segment if we're partitioning it into equal pieces. Okay, Lucy said she could split this segment another way, explain how this is possible. Okay, this is what Lucy is seeing. Lucy's saying, okay, if it's 1 part to 1 part, that means that these are equal parts on either side. Therefore, this point is just the midpoint. Okay, we could also use this argument for 2 parts to 2 parts, 3 parts to 3 parts, 4 parts to 4 parts. Essentially, all of these would just be asking for us to find the midpoint. Okay? And question number 16. 3 vertices of parallelogram are A, B, and C. So I'm going to plot these really quick. 2, -6, -1, 2, and 5, 3. Okay, we're going to find the coordinates of D. So it looks like we actually have 2 possible answers for finding the coordinates of D. And it looks like the D value could probably be somewhere over here in this quadrant, or the D value could be somewhere over here in this quadrant. If we're going with maintaining the order, right, A, B, C, D, then I'm thinking that this area is probably going to be the better place for us to look for that D value. Now, if this is a parallelogram, opposite sides are parallel. So first I'm just going to kind of close this in with what I have so far. Right, that means that this side and this side should have the exact same slope. So this has a slope of up 1 over 1, 2, 3, 4, 5, 6. So 1 over 6. So what we're going to do is we're going to start on coordinate A and we're going to go up 1 and over 1, 2, 3, 4, 5, 6. Okay, so if we go to figure out where this coordinate is, we went 2 off the graph, so that's 7, 8. So we went over 8 and down 5. So it looks like the coordinate for D is 8, -5.